Hello everyone, this is Pulchava. Today I want to do a teardown and review of this piece of equipment. It's Atten ADS1022C digital storage oscilloscope. As you can see, looks kind of familiar. Why does it look familiar? Well, because it's made by Sigland. I mean, Sigland and Atten are the same company, and they are probably peddling this shit under a dozen different brands. As I've heard, LaCroix is selling the higher bandwidth models of this scope under their own brand, which is really shameful. Anyhow, the story behind this scope. I bought it new in about 2009 or thereabouts. Anyway, around the time when Rigol DS1022E became popular thanks to EEV blog. It was why didn't I buy Rigol? Well, mainly because of the price. Because at that time Rigol was around 500 euros in Poland, and this one was about 300, which made quite a big difference for a college student, which I was at that time. So I've had it for what, like 4 or 5 years, and well, I will begin with bottom line. It's shit. I mean, don't buy it, don't use it, don't buy Atten equipment anyway, don't buy their scopes. They are making some pretty cheap soldering stations, which are kind of a good value for money, but otherwise don't buy their shit. Trust me. But let's not jump to conclusions. First of all, something about specs. It's, as you can see, it's a 2-channel oscilloscope. It does not appear like there is a 4-channel model of the same of this scope. Although it's also available with 100 MHz bandwidth and I believe also 60 MHz. So yeah, it has 2 channels, external trigger, obvious probe calibration output, all the ordinary knobs, you know, division, position, some function buttons on the side of the screen, just the bare minimum that is required for a digital storage oscilloscope. However bad it is, it's not a toy. I mean, it's still you know, orders of magnitude better than DSO nanos and what have you. This is, don't get me wrong, this is a real scope, this is not a toy. Although this was the cheapest scope that was available at the time when I bought it. Around, I don't know, maybe like 3 or 4 months after I bought it, I went to the same store and they didn't actually have this one in stock anymore. They had the ADS10 something CML versions, which have wider screen. Whether or not this actually translates to more data you can display, I do not know. This one has 320 by 240 pixels display, which is kind of a standard. I believe it's the same as Rigol DS1052, some Unity scopes, Ovon, and others. Yeah, this one is, as I said, it's 25 MHz, 500 mega samples, which may seem low, but at this sort of bandwidth, it's really plenty. I don't know what is the memory depth in this one. What else? With the scope, I got obviously 2 probes. They are not branded Atten, they are type PA360. it's 60 megahertz written on them. I did not check if they really can do up to 60 megahertz. First of all, because I didn't need to, and secondly, this scope can do only up to 25 megahertz, and so there is really no point. I mean, it's hard to believe they could make probe as bad as not to be able to, you know, work at 25 megahertz. Also, this scope does not really have 25 megahertz of bandwidth. It's flat up to about 18 or 19 megahertz and starts to roll off after that, reaching minus 3 dB at around, I would say, 30 megahertz or thereabouts. Yeah, so the spec is not really that accurate. What else was in the box? There was a CD with the software, which, as you may guess, is kind of the same class as most other Chinese software, which means that it's full of Chinglish, really buggy and not very functional. It serves the purpose of downloading data from the scope onto your PC via a USB cable, which was also included to the scope. But there is the first annoying thing about the scope. I mean, it has a USB 2.0, at least that's what it says, so theoretically capable of about 12 megabits of bandwidth. Well, the application lets you download data from the scope in two ways. You can either download it as a comma separated value file, so CSV, which is rather fast, or you can download a bitmap directly from the screen. So you get the bitmap which shows exactly the same thing as your screen on your scope does. So, well, you would think that, okay, about, well, 256 colors, 320 by 240, how long can it take? Well, about 40 seconds turns out. So this is really sluggish, and to be honest, after I have tested this and found out how long it takes to download the bitmap, I have never used that again. There is also the USB host socket into which you are supposedly supposed to put your USB stick with firmware update, which Atten never released since I purchased this scope, or to download the data onto a stick. I have never tried this because I never had the need to do so. But I suspect it's same as slow as the PC connection. What else do we have? Yeah, that would be pretty much all. So, would I recommend this scope to anyone? Well, no, I wouldn't. I mean, it's not because of the quality of the hardware, because I think it's good. I mean, it's very good considered the price, but to be honest, as with many Chinese products, the main problem of this device is the software, which is shit. I mean, it's so buggy, it has so many, weird quirks, bugs, and it misbehaves when you expect it the least. Good example of that, you have, as in every scope, you have the auto scale button, which is supposed to automatically scale the display and turn on and off all the functions such that you can see the waveform well, just good. Well, it turns out that if your signal is anything close to Mind's frequency, it will lock up. You literally, if you connect, for example, connect the input to I don't know, like a secondary winding of a transformer and press the auto set, the scope will lock up. I mean, it does not respond to any commands anymore. You just have to power cycle it. This is, you know, really, really dumb. Another annoying thing is that you cannot bring the measurements out on the screen so that they are, you know, overlaid over the graph, which seems like a pretty basic thing. I mean, it's something that Hewlett-Packard or Tektronix scopes have had for, I don't know, like 30 years or something, even before I was fucking born. And, you know, this is like a 2007 or 2008 piece of equipment, and it does not have that. It's not that it does not have the capability to do that, because it does overlay measurement data when you use the auto set button, but you cannot kind of, you know, choose the different parameters that you would like to display and put them on the screen. And it's just one of the those are only two stupid things about this scope. Not to mention that FFT is pretty useless. I mean, I have compared this scope. I literally fed the same signal to this scope and MSOX 7054, and well, this scope does not show anything meaningful when you use FFT, really. I mean, and it's very cumbersome to use. So yeah, that's pretty much all she wrote about this scope. So let's do the more interesting thing. Let's take it apart. And by the way, I did not I do not follow the EV blog rules. I have turned it on multiple times before. As you can see, it was not taken apart before. I mean, it does have still the warranty seal on it, actually two of them, which obviously are worthless right now because this scope is not under warranty anymore, so I couldn't care less. So let's go. Okay, so let's go with the teardown. I mean, okay, so I have never really taken this apart, so I will first have to figure out how. Well, yeah, so we have two screws here on the bottom, and I cannot see anything else, to be honest. So yeah, first things first. Warranty seal 1, 2, and 3. Now the scope is officially not under warranty anymore. Okay, so let's take out those two screws. I might need a different screwdriver. Yeah, looks like it's coming apart. At last. Well, okay, so what do we have here? So we have a pretty thick shielding can. It looks like it will just snap open. Yeah. But it's kind of thick still. I mean, it's soft, but it does feel pretty rugged, I have to say. Yeah. And there we go. Okay, so as I said, the shielding can is kind of thick. I mean, it feels good. This it's what, like 0. Yeah, I think it's 0.5 millimeter sheet metal. So pretty hefty, I'd say. So how does it look on the inside? Get this lamp in other way. So yeah, we have two board construction. One of those boards is the power supply, which is not shielded in itself. I mean, it's not shielded from the other parts of the circuit. At least the analog front end is shielded. I mean, yeah, we'll see whether or not we can take this apart. So what else can we see from here? We have a cooling fan, which I knew it was there, but it's not annoying at all. There is a you know, power cable. What else? So yeah, it does have a, you know, good old clunking power switch. Curiously enough, it's only held in the PCB with solder connections. I mean, it does have some threaded holes, but those are not attached to anything. The IAC connector does have a nice grounding lead, which is quite firmly attached to the chassis and its hitch shrunk. So, well, it looks quite well by my standards. We have, so let's look at the power supply. So yeah, we have a fuse which is not soldered down. It's in this, you know, like a plasticky socket with the transparent cap on it. I mean, I like those sockets. I use them myself. What else? So we have a few. So yeah, we have a few capacitors, another capacitor, a foil capacitor, a common mode choke. What is this one? I cannot see it from here. I mean, some sort of TO220 package. It's okay. I don't know. I will have to take the power supply out. What else? We have a big cap. It's Aishi brand. Well, it's not like I expected Rubicons or Panasonics in this one. What else? Well, yeah, we have a Rubicon. This small cap here is branded Rubicon, but you know, fuck me if that's a real Rubicon cap in something like this. Surprisingly enough, well, the output capacitors from the power supply are also Rubicon branded, but yeah, I also suspect those are fake. We have a bunch of optocouplers. We have you know, an isolation slot going around and separating the mains part from the secondary side. We have an optocoupler at funny angle. It's a true hole design. It does say, come on, focus. It does say Siglant on that, and some arrow which I guess indicates which way it goes into a wave soldering furnace. So yeah, there is one clue that it was not really made by Atten but by Siglant, but it's kind of interesting thing that they did not buy in the power supply from an external company, just rolled their own power supply. And yeah, there we have the main board. I mean, I will have to take it apart, but from here I can see, you know, some Hynix chip, which is RAM, the expansion flash, analog device is BF531, Altera Cyclone, EP1C something, so this is kind of an old tech. Yeah, we have the pass-fail output BNC socket, some unpopulated footprint right here, something marked UPS051, some NXP chip over here. Well, we have what are most likely ADCs, and they've made this, you know, pathetic trick with scraping the markings away. Those have definitely not been lasered off, so we will see what we can get from that. Yeah, we have a bunch of, you know, other chips, probably, you know, like control signals and such. Some chip branded AD over here. Pretty compact design, you know. So yeah, let's take it apart further. Okay, the power supply. As I expected, and probably everyone else also did, it's a single-sided, entirely through-hole construction, obviously wave soldered. We have some additional solder to keep with to help with heat dissipation on the secondary side. As for the safety side of things, well, it doesn't look bad. I mean, you have there's an isolation slot here with an optocoupler. Have a few holes under the transformer, probably for cooling. Another slot with an optocoupler. The slot goes over here. Over here we have a few holes, and I was kind of concerned with this part here, but there are also isolation slots, and it turns out that that there is nothing actually going over those slots. So yeah, I would like to see this clearance here kind of, you know, a little bit bigger, but I would say it's adequate, really. So the top side, I mean, okay, so we have this, as I said, we have the IAC connector. Let me see if I can, yeah, okay. We have an IAC connector, a fuse holder, a switch, pretty hefty one, I must say. We have an NTC over here, bridge rectifier, common mode choke, the main input cap. What's this device here? Let's see, it's it's TOP TOP245YN. The logo looks like power integrations, and it's a what, 1, 2, 3, 4, 5, 6 pin device, which makes me think it's some sort of you know, integrated switch mode power supply controller, perhaps. I mean, it's clearly on the primary side, but I don't think it's PFC, because I would expect the cap to be further from the bridge rectifier, and also I would expect a big inductor for PFC. And having two inductors here and here clearly shows that well, I think this proves that this is actually the controller for this power supply. Obviously those optocouplers are feeding back the output rails to the control chip over the isolation barrier. We have two more TO220 chips, both screwed down to a heatsinks. This one on the smaller heatsink is MBR760, so it's a big Schottky diode. And the other one, well, you know, LM317T. So yeah, we have a good old-fashioned LM317 in this one. And there are a bunch of caps, bunch of, you know, resistors, capacitors, that sort of stuff. Nothing fancy, really. Shit, it doesn't focus, whatever. I mean, so yeah, that's the power supply. It uses some sort of, you know, wire to board connector, and it does disconnect only at the main PCB, and the connector is secured with some sort of, you know, elastic red gunk. It was cable tied to this screw which holds the fan, and it was rubbing against quite sharp edge of the shielding can. Oh, by the way, it was also connected to this wire, which looks like it could be a supply for the backlight. We have a small circuit with an inductor here. I think it could be a boost regulator to generate the high voltage for the backlight, which I presume in this case is of electroluminescent or CCFL type. It's okay. How do we take this stuff apart? Okay, there is nothing bad to be said about this, you know, red gunk, really. I mean, it holds too well. So, you know, this is not going anywhere anytime soon. I have to tell you that's one annoying piece of equipment to take apart. Looks like I need to remove the fan in order to remove the power cable. Okay, the fan is JSL branded, not a familiar name. Shit. That's interesting. So yeah, apparently I have pulled out the shaft out of the encoder, and what's better, a part of it snapped off So a note to myself: buy an encoder while you're at it. But it does seem to work. There's a rubber keypad membrane. So I'm generally trying to figure out how to take this thing apart, because as you can see, the shielding can, that part and that part of the shielding can is riveted to the main piece of steel, which is, by the way, much thicker than the rest. I mean, I think it's like 1 millimeter or something. If I remove those two screws, the top of the shielding can should pop out. At least I hope so. So yeah, that's probably the order in which they were putting this together. Okay, so I have no idea how to take out the flat flex cables. Okay, there we go. We have some shake-proof washers screwing the main PCB to the bottom of the chassis. Okay, let me tell you, this was not an easy thing, to take apart. Clearly any kind of repair or, part replacement was not planned for this. Okay, so let's do more of a close-up video. Okay, so by the way, I am recording this thing with my smartphone, which you may have already noticed, but this is the best shit since sliced bread, really. I mean, I paid literally $6 for this, and it turns this into that. Okay, that didn't work out so well. So yeah, this macro lens, however cheap that was, it turns something like this into something like that. I mean, this is, I am not an expert, but this is really, really impressive for a few dollar smartphone accessory. Okay, so what do we have on the PCB? So let's start with this section, which is clearly the processing part of the business. So yeah, here we have a, what is it? S29GL032 flash memory from Spansion. Next we have a Hynix H57V 1262 GTR RAM memory. I believe it's SRAM. There is a chip from NXP, which is ISP1362B0. I think it's some sort of communications chip because it's right next to the USB socket and the RS-32 socket and the pass file output, which probably doesn't have much to do with it. We have a piezo buzzer, well, completely off-brand. Some Rubicon cap. I mean, all of those are Rubicons, but it's really, really hard to believe those are real, genuine Rubicons. It's in such a one hanglo equipment. If those were, I would be really, really surprised. So there we have a UPS 051 IC. As you can see, no manufacturer logo on it. I have no idea what it is, but on the contrary to other chips, like for example this one, the markings have not been lasered on. I mean, here you can see, if I get the, you can see that the tiny laser lines. I mean, it's even more evident on for example ST microelectronic chips, but with this one the markings have been definitely printed on the package. So I don't know what that is or what does it do. It is connected to the it's definitely connected to the LCD connector, so presumably it's it's some sort of, I don't know, LCD driver or something like this. Yeah, we have like HA04. That's a logic chip. What else? Yeah, we have a board. I mean, it goes from the last pin of this QFP package. Down, it's secured with some hot nut, and it goes over to one of the pads from an unpopulated QFP footprint. What else? Yeah, we have an unpopulated double row pin header. Well, that's the JTAG. For which chip, I don't know. Yeah, we have the processor is an Analog Devices ADSP-BF531 Blackfin DSP, which seems to be the really favorite DSP of all the Chinese manufacturers. The FPGA is Cyclone EP1C 60240C8N, which is Cyclone 1 series, which is kind of old tech. As you can see, by the way, the thing to notice, there is a complete lack of BGA devices of any kind on this board. I mean, it's very simplistic. It's, you know, single-sided load. There is no components whatsoever on the bottom side of this. So yeah, it's, well, I don't say it's bad. It's just that, for example, in Rigol you can see some, you know, land grid patterns. I think the main processor is a BGA. By the way, the soldering on this one does look nice. I mean, I've seen better, but there is really nothing really wrong with this. Yeah, I mean, I think the solder could have been reflown a little bit more, but apart from that, it's not bad at all, I have to tell you. Yeah, here we have the ADCs, what are, I presume, ADCs. Those are, there are only two of those. We don't have the kind of arrangement like in Rigol, where you have what, like 5 or 10 ADCs being interleaved. We have only two, and well, if the spec does not lie, those should be at least 250 megasample per second ones. And by the way, the higher bandwidth models of this scope do not have any higher sampling rate, so I believe the same identical ADCs would be used also in the higher spec well, models. As I said, they have scraped off the markings. I mean, I don't think there is anything I can do to get those back. Yeah, Yeah, but those are clearly ADCs. The good question is whether those are genuine analog devices ADCs like those in Rigo, or are those some off-brand clones, which would not be surprising. I mean, I think it was Mike Harrison from Mike's Electric Stuff who tore apart one of those, you know, like pen scopes, and there was a clone of analog devices high sampling rate ADC, which means they are out there, and those might be of that kind. We have another cap in here. We have an NEC relay, actually two of those. Some different chips. I mean, there is one interesting chip, which is this. It's AD1851 RZ, or RZ as the American guys would say. Yeah, we have some 4000 series CMOS, more 4000 series CMOS. Those are analog multiplexers. P274, no idea offhand. Same P274, and the third one is also P274. We have a free leaning, I would say, 7905 negative voltage regulator, which provides power probably to some of the analog circuitry. Well, this small chip is 6C. It has 6C written on it. Oh no, sorry, it's 8C. I mean, I know you can't make it out from here, but yeah, that's due to some poor lighting. But that's a 8CP272C, and it does have a Texas Instruments logo on it. Yeah, there is another NEC surface mount relay. The B and C sockets are not of bad quality. I mean, they feel pretty rugged. So let's see what's under the shielding cans. They are a true hole solder type, but the top cap is, I think, only a crimp on. I mean, those tabs fold over and interlock the whole thing. So let me get those away. Okay, we're in. We have a few NEC relays, probably for switching, you know, coupling modes and stuff. So we have an AD B7A chip. We obviously have HC595. We cannot live without 7000 series. There is an AD8330 over here. We have a few SOT23 devices. A1W, A4T, and another A4T and another A1W. I suppose this could be a differential amplifier. You have BLK2 in being a 5-pin SOT23 package. What else? We have some more transistors, A7 or SOT23s. We have A7W, 43W, free EM, and I think everything else is passive components. Yeah, and obviously the other channel is... Interestingly enough, those pin headers, I mean, we have three different pin headers, two out of which are populated, this and this, and one which is not, which is this one. So my theory would be that this one is the JTAG for, and probably some diagnostic stuff for the FPGA and perhaps whatever was in this place, and this header is most likely the Blackfin JTAG, and this header, to be honest, I have no idea. I believe it could be some sort of programming interface for this NEC chip over here. Sorry, NXP. Which is kind of supported by the fact that it does have a 12 megahertz crystal, clearly for USB. It may have some sort of programmable logic inside, so you know, JTAG wouldn't be surprising. And there is also, what the fuck is that? That's a P40. Okay, it's an, I think it's an alpha and omega logo, which are, you know, MOSFET company, 4405. It does not seem to have a footprint that would be typical for an SO package MOSFET, and neither does it have any inductor round, but this kind of doesn't fit the fact that alpha and omega semiconductor doesn't do much else than MOSFETs and integrated, you know, switch mode converters, at which they are pretty good actually. Here we have, well, that's a little analog devices chip. I mean, I thought it was some sort of logic. I didn't pay much attention to it. It's ADS1022C. 8184, and the one here is ADCMP 66 to BRQ. Yeah, and here you can see AD 8184. I mean, this one is definitely a comparator. What is this one? I have no idea. It does not ring a bell. So yeah, that's pretty much all for the main board. So here we have the interface, the keyboard PCB. We have some screws which have those plasticky rubber washers, which kind of keep the screws from falling out, but for some reason they forgot about this one, and this one does not have the plastic washer, and for some reason it is not in the mounting hole anymore. We have several chips. So what are they? HC595, HC595, 4051, 4051, HC393, and that's all she wrote. So yeah, not really fancy. So I have assembled this thing back together. As you can see, it works. I mean, even the encoder from which I have pulled the shaft out works as intended. So yeah, seems like no permanent damage has been done. Yay, a success. Hi. Some afterthoughts after the teardown and, well, successful reassembly of the scope. First of all, the mechanical build quality. First of all, this thing was surprisingly hard and non-intuitive to take apart. I would say that the ease of service and repair was definitely not one of the main goals of the mechanical design of this thing. But other than that, the materials used in the scope are rugged enough. I mean, it feels solid. I mean, aside from the fact that the sheet metal which was used to make the chassis had some rust on the edges. There is not much to complain about in terms of build quality. As for the PCB assembly quality and general design quality, I think it's pretty adequate for any device, which means that it is very good considered the price range in which this device was. The revolve soldering is of reasonable quality. I've seen better, but I've seen much worse. There is a single bodge on the board, which, this is not a game breaker. I mean, in every design, shit can happen, which you have to fix with a bodge. I mean, it's if there was like 20 bodges, I would I would feel that I have a reason to complain, but with one bodge I don't. Um, yeah, uh, the component selection is pretty good. I mean, the usual Chinese combo of Blackfin DSP, some Hynix RAM expansion flash was kind of expected even before I opened the device. Um, which really means only one thing, that the Chinese guys get huge discounts on analog devices parts, and that the Blackfin DSPs present really good value and performance for money. Um, on the side, as a side note, it seems that Chinese manufacturers really like analog devices components. What's the reason behind this? No idea. But it's kind of easy to notice that all of those low cost uh, test and measurement devices from China contain almost exclusively analog devices chips, at least for analog processing. Uh, all the logic is from TI, and even the stupid 7905 regulator, which could have, which could, well, quite as well be sourced from a no-name Chinese company, is actually an ON semiconductor. Um, as for the capacitors, I don't know. Maybe some guys who are more familiar or more or are more of an experts on this topic could express their opinion if they think those caps are genuine or not. But I personally would say they are not. Not this price range, you know. So yeah, it's a very very simplistic design. Um, One of the things to note is absolute lack of BGA or QFN or DFN packages, which was uh, which was done, I think, to save the cost, because most assembly houses will charge you an extra for BGA packages, because especially the larger ones like the like a DSP, uh, the assembly house would have to kind of adjust the reflow process, uh, or just monitor the reflow parameters more tightly for it to work. And with only SOIC QFP and other similar packages, this is not so critical. Also, the you know economic pressure is reflected in the fact that there is only a single-sided load. I mean, it's quite typical that a double-sided loaded board will cost you anything from 1.5 up to 2.5 times that what a single-sided loaded PCB would cost. So yeah, that's attention. I I think it leaves no doubt that the cost was the absolute primary objective here. Another thing worthy of notice is that there was no external acquisition memory on board. I mean, in almost any scope that was torn apart and photographed that I have seen, the acquisition memory was actually a separate external chip from Hynix or whoever, um, and uh, and in this scope, I presume the acquisition memory was implemented inside the FPGA, which you know, it's kind of expensive way to do it, because memory takes a lot of silicon area, and silicon area in an FPGA is very expensive, even if you use a very old FPGA like a Cyclone One. I suppose it could have theoretically been possible to share the memory of the DSP, just to share the same memory between the DSP and FPGA, but then I would expect the SRAM chip to be somewhere in between DSP and FPGA. So I guess it's more likely that the acquisition memory was implemented inside the FPGA. Obviously, the scraping of the markings from ADC chips, um, you know, makes you think whether or not those are genuine chips. And to be honest, I don't know. We have seen fake ADCs which did not have the markings scraped off, but we have also seen genuine ADCs from TI, for example, in Rigol DS2000, which did have the markings removed. So I don't know what's the point really. Yeah, so all in all, I think it's quite a neat design. I mean, it definitely does work. If it could have been quite a good scope if it wasn't so, if the software wasn't so bad. But obviously, there, after, you know, this teardown, and when you compare it to how the Rigol DS1022E looks like on the inside, you immediately know where does the price difference come from. I mean, in Rigol you had a 1 gigasample 1 gigasample per second sampling rate. You had 5 dual channel ADCs which were being interleaved, and there is a separate CPLD for generating the timing for the ADC chips. There is an external acquisition memory. I believe the FPGA was also different. I believe it was Xilinx, but don't quote me on that. Yeah, and in general, I don't think there were any bodges in Rigol. And also, the stupid buzzer was TDK. Yeah, I mean, you know, when I decided to do this teardown, I did not expect to find any unusual stuff inside. I was more interested in how did they build this. Well, this scope was obviously built down to a price, and I was I was wondering how far did they go, and it turns out that, well, they definitely did not do some things that they could have to reduce the cost even further. I mean, it does have some indications that, you know, some bean counter was standing over the engineer and telling them to shave off every penny, but in the end it didn't go to any extreme extent. You know, there is no flood of off-brand chips and, you know, Capcom capacitors. There is no you know, the entire jungle of bodge wires on the PCB. The soldering is decent, which is not always the case. And right now I'm thinking about the current power supply, which turns out that looked almost as if it was entirely hand soldered, even the SMD boards. So yeah, well, it could have been much worse, but the hardware quality is definitely lower than Rigol. Um, Again, this is not to say that this one is bad. Well, Rigol DS1022E is exceptional in this regard. I mean the value and build quality for money. But this one is okay. If it wasn't for shitty software, this could have been a kind of a solid piece of equipment. So yeah, I think that would be all. So thank you guys for your attention and see you next time. Bye.